Your veterinarian can read something about your home life just from the intake form, not from the medical history, from one question. Does your dog sleep in your bed? The ones who answer yes, and research consistently suggests that number is higher than most pet owners will admit, show up with something measurable in their stress hormone panels, something that differs consistently from the dogs who sleep alone on the floor. The question is what exactly is being measured and whether it belongs to the dog or to you. Most people who allow their dog into the bed will tell you the same story. It started as a one-time exception, a thunderstorm, a puppy that wouldn't stop crying, a night when the bed felt too large and too quiet. And then it simply became the arrangement. They'll also tell you what they've heard from trainers, from forums, from well-meaning relatives who read something once in the 90s. That it creates dependency, that it confuses the dog about hierarchy, that a dog sleeping elevated beside you will start to believe they run the household. That warning has circulated for decades. It carries the weight of common sense. And nearly every serious researcher who has examined it has found no evidence it holds up. But here's the problem. Disproving the dominance myth wasn't the interesting part. The interesting part was what the research found underneath it, what was actually being exchanged in that bed across all those years of shared sleep that nobody had thought to measure. In 2022, researchers at Eötvös Loránd University in Hungary, one of the leading centers for canine cognition research in the world, published findings from a polysomnographic study examining sleep EEG data in family dogs sleeping near their owners. What they found wasn't primarily about the humans, it was about the dogs. Dogs with stronger measured attachment to their owners showed distinct differences in spontaneous sleep EEG parameters, specifically in the slow wave stages associated with memory consolidation and emotional regulation. Their brain waves, during the deepest stages of sleep, reflected the security of the bond. Not as behavior, as neurology. 61% of the securely attached dogs showed elevated slow wave activity compared to anxiously attached dogs in the same study. 61%, which means more than half the dogs sleeping soundly beside their owners weren't just comfortable. They were doing the biological work of a calm, regulated nervous system. The kind of processing the brain only performs when it has no reason to be on alert. But the more interesting finding came from a different direction entirely. A 2015 study from Azabu University in Japan, led by Miho Nagasawa and published in Science, measured oxytocin levels in dogs and their owners during extended mutual gaze. The result? The same neurochemical loop that activates between human mothers and newborns. The same pathway in two different species. Activated simply by sustained proximity and attention to each other's presence. But the more interesting finding was what happens to you. The oxytocin loop runs both ways. When a dog settles against a human body at night, the warmth and rhythmic breathing trigger the same sensory input as being held by another person. And the human brain, it turns out, cannot easily distinguish between the two. Research tracking EEG activity in humans co-sleeping with their dogs found elevated theta wave production during the early stages of shared sleep. Theta waves are the brain's signature of its most restorative phases, the stages where emotional memory gets processed, where the nervous system genuinely recovers rather than simply pauses. Your dog isn't just sleeping next to you. Your dog is physiologically regulating you. That distinction matters more than it first appears, because it means the co-sleeping arrangement isn't a one-sided comfort, the dog seeking warmth and safety from the human. It is a mutually regulated biological system. Two nervous systems across two species doing something that 15,000 years of shared evolution prepared them to do. Each body in proximity to the other, producing exactly the neurochemical signal the other needs to sleep deeply. The arrangement is not sentimental. It is ancient, and it runs in both directions simultaneously. Compare that to what happens in dogs consistently separated from their owners at night. A 2019 study monitoring cortisol concentrations in dogs across different sleeping arrangements found that dogs routinely sleeping alone in a separate room showed measurable cortisol elevation in the early morning hours, the body's stress response activating before the owner was even awake. In approximately 47% of the sample, nearly half of those dogs waking in low-grade stress, not because anything in their environment had changed, but because the body they were biologically calibrated to was behind a closed door. This points directly toward the mechanism. Because cortisol doesn't spike randomly, it spikes in response to perceived separation from a primary attachment figure. In human infants, that pattern is extensively documented. In dogs, the research is younger, but the physiological signature is almost identical, which tells you something precise about what category of bond this actually is. Not affection, attachment. And attachment, in every species studied, operates below the level of conscious choice. Dogs are the only animal domesticated before the invention of agriculture, before farming, before cities, before written language. Roughly 15,000 years ago, wolves, most tolerant of human proximity, began a slow genetic convergence toward what would become the domestic dog. Not because humans selected for obedience, but because the overlap in social structure created survival advantages for both. In 2017, geneticists studying chromosome 6 in domestic dogs identified specific genetic insertions in a region associated with hypersociability and human-directed contact seeking. Insertions that do not exist in wolves. The drive to be near us is not learned behavior. It is written into the genome, selected for across hundreds of generations because proximity to humans improved survival outcomes. Here is where oxytocin enters with its full biological weight. Oxytocin, the same neurochemical released during childbirth, during nursing, during the first hours a parent holds a newborn, is released in both dogs and humans during sustained positive physical contact. Think of it as the body's confirmation signal for safe attachment. The amygdala, the brain's threat detection center, actively downregulates in the presence of oxytocin. Your dog's brain, sleeping against your body, is running a continuous low-level message to its own fear system. Stand down. Your nervous system is doing the same thing. Studies measuring heart rate variability in co-sleeping human-dog pairs found that within roughly 20 minutes of settling, the cardiovascular rhythms of the two began to converge, the dog's system subtly synchronizing with the human's. Two amygdalae across two species mutually downregulating through the night, not metaphorically, measurably. And your dog has been doing it, instinctively, without training, since the night you first let them stay. All of that science collapses into a single moment you have probably already had and not fully registered. The moment you woke at some unremarkable hour and found your dog already awake, watching you. Not barking, not restless, just watching, with an expression that registered, even through the haze of interrupted sleep, as something more deliberate than curiosity. Here's something that rarely gets mentioned outside veterinary behavioral research. Dogs in secure attachment relationships have been documented orienting toward their owner's face during quiet, into-sleep intervals. Not when startled, not when dreaming, but in the stillness between sleep cycles. They turn toward you, in the dark. Not because they need something, because your face, during sleep, has become the primary environmental anchor their nervous system uses to confirm safety. A 2021 study from the University of Lincoln in the UK examined cortisol profiles and attachment behaviors in dogs across co-sleeping and separated sleeping conditions. Dogs in the co-sleeping condition showed significantly lower nocturnal cortisol readings and more rapid returns to slow-wave sleep following brief arousals. The bond, in measurable biological terms, made them more resilient, not more dependent. What your dog is communicating when they sleep beside you is not that they need you in the way a child needs a parent. It is that they have chosen you as the fixed point in their environment, the signal their nervous system reads as safe. That is not dependency. It is trust expressed at its most fundamental level. Not in a gesture, not in a behavior, but in the willingness to be unconscious next to you. To be that unguarded, in the presence of another living creature. If this changed how you see the arrangement you've had for years, maybe without ever fully understanding what it meant, subscribe. There's more here that takes the science of animal behavior as seriously as it deserves to be taken. Leave a comment with this. Where does your dog sleep? At your feet? Pressed against your side? Or directly on top of you? The position maps onto specific attachment patterns, and I read every single one. Next, what dogs actually experience during their dreams. The brainwave activity, what shows up on EEG during REM, and what researchers believe they are reliving night after night. Stranger than you'd expect.